And what I want you to do is think of this as an equation as what would you do if it was just regular old 3x minus 1 is 5? What would you do first? So you'd add 1, right? You'd add the 1 over. You get 3x equals 6, and then you take the inverse and go. So what do you do with that matrix? You add it to the other side. Now, will those matrices match up? Are they the same dimension?
Yes, they are.
Yeah. As long as they're same dimension, you can do it. So what happens here is that you just have to follow order of operations, but you're still throwing it in with some matrices in. Okay? Now, obviously, you still have to do the inverse of the matrix next to the x. And then when you type in the other matrix, you could probably do this adding or subtracting in your heads. If you want to write it out, write it out. Just take a second, see what you get. It's funny when you start pressing some of these buttons, you start to see that the calculator even takes a second to do it because it goes, and then it does it. You guys get some fractions too?
Yeah, 32.
Good? Okay. Where are we at? All right. So what we've got here is you agree that you're going to have to take the inverse of the matrix up there, right? Okay. So what I want to do is I'm going to create that matrix right away. Your output here. Do 2 by 2. And 4, 3, 6, and 2. Now we have to take the inverse, we get the inverse one. Now, the other matrix, I have to add all the ones on the matrix on the left circle to the one on the right. Because it's minus, so it's going to be adding. So what's 4 plus negative 1? So we're now plus 2 by 2. 4 plus negative 1 is 3. 6 plus 1 is. And then what? Enter. Then enter, enter. That is it. Just be careful when you're adding to something. Don't get a personal plan of
those tiny little circles that you stick your hand to.
You take the determinant of the coefficient matrix, put it over 1, distribute into the original matrix, flip-flopping your diagonals and negating the others. No, there's no reason, there's no point at all.
There's no answer.
Were you supposed to get some grading fractions?
Yeah, did you guys get on that one, sorry, I mean to skip ahead here. On this one for a solution, did you guys get 33 over 10, 13 over 10, 17 over 5, and negative 3/5?
Yep.
Yes.
Then you did it just fine.
I did it wrong.
You got to be careful on how you set them up. If you're not getting those solutions, one thing I will suggest then, try to do the addition by hand before you type it in the calculator and make sure you do it right. Okay? So here's another one like that. Very similar. Try this one. Bless you. Oh, the sound of the droning away on the buttons. Yes, sir.
Even after I went back to New York State. So are we supposed to add them together and then take the inverse and see and the equations?
No. Because if it was written, if this was 3x minus 1, can you combine those? You have to add this one over there. So what you're doing is you're adding 2 plus 8, negative 2 plus 2, 3 plus 6, 1 plus negative 4. If this was an addition symbol, then you'd be subtracting those two together. But take this inverse to that. You're working. It sounds like you're working backwards. Okay. On this one, did you guys get 19 over 10?
Yes,
Negative 3 over 10, negative 7 over 10, and 9 over 10.
See,
Hit math enter enter.
I did it.
All right. Now, what do you think this is going to allow us to be able to do eventually?
fun things that aren't.
Solve systems.
I got the right answer.
This is going to allow us to solve systems. Let me show you a quick example. What I'd like you to do real quick with this example is I want you to create a coefficient matrix and a solution matrix. I want you to create a coefficient matrix and a solution matrix. Coefficient matrix, we did that yesterday with Kramer.
Find the determinant.
And a solution matrix. The solution matrix is just going to be a column matrix, isn't it?
Should we be? Wait, are we trying to find an answer?
Hold on. All I'm asking you to do is create a coefficient matrix, so hopefully it would look like this. And it has to equal. Now, here's the question. A 2 by 2 times what gives you a 2 by 1?
I mean, 1 by 2.
When you're dealing with the multiplying matrices, remember, it was 2 by 2 times something to equal a 2 by 1. What did that something in the middle have to equal?
2 by 1.
It has to equal a 2 by 1. So that way the number, those match up. Now that means that right here in the middle, there should be that, right?
Yes, you just don't just substitute in the
You would. But now, if I'm multiplying things together,
You should invert it.
just inverse it.
Boom! You did the math.
To get my solution set for a system of equations, once you create a coefficient matrix, the inverse of the coefficient matrix times your solution are your answers.
So
There's
everything
another
you
way
just
to,
learned,
everything that I've taught you
it's useless.
is useless now.
That's fantastic. That's what I love.
Whoa, yeah, you gotta learn to walk before you run. Once again, if I'm looking at this, if I'm going to solve a system of equations via inverse matrices, all I have to do is take alpha y, oops, wrong button, alpha y equals 2 by 2, create my matrix, negative 3, 4, 2, negative 1, take the inverse of that times, is this a 2 by 1 or a 1 by 2?
2 by 1.
2 by 1.
What are we times it by?
5 and negative 10.
Oh, 5 negative.
And your answers are,
Negative 33 over 9.
then you typed in something wrong.
It's negative 7.
What I'm doing here is by taking the coefficients out of a system, negative 3, 4, 2, negative 1, they have to equal 5 over negative 10, 5 negative 10 for your column matrix for your answer. In order to multiply a 2 by 2 times something to get a 2 by 1, that something has to be a 2 by 1. That sets you up to do inverse of matrix A times matrix B to give you the answers for X and Y. Now, if it was a 3 by 3, what would change?
2 by 1.
Yeah, it becomes a 3 by 1. All right. This is where we're heading. We're heading into the realm of solving systems via keystrokes. Yeah, all those 3 by 3s and stuff you had to crank out by hand, all you had to do was. Because that's what we do. There's always some easier way of doing something eventually. This is the easiest way to do things. Now, when it comes down to the test, obviously I'm still going to have you crank out a Kramer's rule by hand. You will have to do a 2 by 2 by hand. I will tell you that right now. But when it comes down to the other stuff, the calculated portions and all that, we're going to infuse word problems and other different things in this, and that's what we're going to work on for the next couple of days after this. Yes, sir?
Going into the test.
We're going to do a 2-part test. We're going to do the non-calculator part the last 20 minutes or so of class on Monday, and then the regular test on Tuesday. I don't think it's going to take you guys very long to do this at all. Okay? Do you want to try one more inverse matrix real quick?
Yeah.
Come on, we'll do one more. Do a 3 by 3. Solve a system of a 3 by 3. We got a minute here before I can give you some problems. You can probably do this right in your calculator. Thingy, yes. God, so easy. There, you probably did something wrong. Yes, sir. I'm a jerk. Now, what's nice about being able to do it this way now, when you guys take the standardized tests and stuff, if you see some system things, use inverse matrices. Did you get it? Nice. Did you guys get?
Yeah.
Yes.
Yay! Let's do some problems. In 4.4, I would like you to do so this is on page 227, 29 through 32. It's all calculator work. Come on. Page 223, 233, 26, 28, and 34, 36. Okay? And I'll rewrite that down on the smart board.
That's a lot of stuff.
It's all calculator. Jeez Louise.
Yeah, there's a lot of clicking. Literally the sheet, answer sheet's just gonna be a little block.
We'll work on those. Tomorrow what we're going to do is we're going to go backwards through the chapter and start at the beginning and start working on the word problems. But now we know the easiest ways to solve these things. I want you guys to be able to pull the information out, extract the information, write systems, and solve the calculator. Okay? Questions?
Well, I got to